We want to graph g of x is equal to negative 1/2 times the absolute value of x plus 2. And we want to use our knowledge of transformations. So first we want to identify our parent function. In this case, our parent function is the absolute value function. Y is equal to the absolute value of x. So to graph that, you make a mental table. We know that we can put in negative values, 0, and positive values. The absolute value of 0 is 0. The absolute value of 1 is 1. Absolute value of 2 is 2, and so on. So the right-hand piece of this graph is a line with a slope of 1. But since the absolute value of negative 1 is positive 1, and the absolute value of negative 2 is positive 2, we end up with the left-hand side, which is a line that has a slope of negative 1. So here's our parent function. Now we want to identify the various transformations that have taken place. And if we look at our function, we have a negative. We also have a 1/2. We're multiplying by a negative 1/2. And then inside here, we have a plus 2. So all three of these are going to create a transformation. Now, I always recommend that you shift last. So if you see a shift, it's okay to identify it first. Just be sure that you list it last. And we do have a shift in this case. We have a shift here coming from this x plus 2. So remember, that's going to move us left 2, but I'm going to list it last. Now we have a negative out in front. That's the same as multiplying our parent function by a negative 1. In other words, the negative is out in front of our parent function, so that's going to be a reflection. So we're going to reflect over the x-axis. But then we also have multiplication by 1/2. So that's essentially like taking our parent function f of x and we're multiplying by 1/2. Remember, f of x is just a fancy way of writing y. So essentially we're multiplying our y values by 1/2. So that's causing a vertical compression. So we know with the reflection that the v is then going to be opening down. Now the vertical compression, if we multiply our y values by 1/2, then the slope of my branches changes. So for example, my branch on the right-hand side, that piece used to have a slope of 1, but with a vertical compression, my new line, or the right-hand side of it, would end up with a slope of 1/2. But then we've reflected it down. So essentially, before I actually go and graph it, if the v is opening down, we'll end up with one side that has a slope of positive 1/2, and the other side that has a slope of negative 1/2. Since this v is basically made up of a piece of two different lines. But then the entire graph is going to be shifted to the left 2. So check your graph against mine. Again, your v should be opening downward. The vertex of your v here should be to the left 2, so it should be at negative 2, 0. And then your two lines, one will have a slope of negative 1/2 and the other will have a slope of positive 1/2.